Hi there, Chem Coach Powers here, and today we are talking about chemical names and chemical formulas. I want to be able to have you be able to write formulas, okay, for the names for ionic compounds, okay, including those with polyatomic ions. And I also want you to be able to, sorry, hang on one second. There we go. All right, we're trying something new here. All right, so I also want you to be able to use a stock system to name the ions of the elements that can form multiple charges. Okay, so as we go through here today, your criteria for success is going to be that you are going to name any ionic compound formula if I give it to you. And then if I give you the compound name, you'll be able to write its formula. We're also going to be able to do this with the not just the binary ionic compounds, but the polyatomic ions, and with the molecular compounds as well. Okay, so our objective here today has been covered, and now we are going to cover the idea behind ionic nomenclature. Okay, so basically, you know the difference between the molecules and the ionic compounds, right? So they're different things. And first of all, if we look at a formula, we have to be able to identify whether or not it's ionic or molecular. So if you look at the first example here, we have C8H18. You should be able to look at that and identify that that is a molecular compound. And so it's going to have a different way of naming. Now, it's important for us to name things so that we know the number and types of atoms in a compound. But then we have to have two different types of names because we have two different types of compounds. And so we have these molecular names and these ionic names that we're going to be talking about. So the Al2SO43, aluminum sulfate, is something, it's an ionic compound, and so we want to be able to name that, okay, in a different way than we would name a molecular compound. All right, so monatomic ions, things like magnesium 2+, chlorine 1-, these things you need to be familiar with in terms of looking at the periodic table and being able to identify what their ionic charge is. Okay, so when I tell you, hey, look at the periodic table and find sodium, you're going to be able to say, oh, sodium has a 1+ charge, right? If I say, hey, look at oxygen, you're going to be able to identify that oxygen has a 2- charge. Okay, and so when we're naming the monatomic ions, when we name the ion itself, it's really easy. For instance, for magnesium, we would just say the magnesium 2+ cation, and for chlorine, we'd say the chlorine anion or the chloride anion. Okay, so when we name the actual metals, the cations, we just name them straight like they are. But when we name the nonmetals, we would say IDE at the ending. So it's a chloride anion and it's a magnesium cation. Okay? Now, the stock system is a different way to name things, and you need to have that stock system identified in order to name atoms that have more than one ion. So for instance, in this case, we see iron has a 2+ and a 3+ charge. Well, we would use the stock system of naming in order to name iron. We'd want to be able to identify which iron it was that we were talking about. Okay, so if you have an ion that has more than one charge, you're like, Powers, how do I know? Well, most of those transition metals in the D block are going to have more than one charge. But we're going to show you a little table here in a second that will give you an idea of which ones do and which ones don't. Anyway, when you have something that will have more than one charge, you're going to use Roman numerals in parentheses to signify the charge. So here you can see the iron 2+ ion has a little Roman numeral 2 right after the iron. The iron 3+ ion has a little Roman numeral 3 right after the word iron. This is indicating that it has a 3+ charge. Now, there are some exceptions. For instance, zinc only forms a 2+ ion. Silver forms a 1+ ion. And so if it only forms one ion, like zinc or silver, you do not need to include the Roman numeral. Okay? So don't include the Roman numeral if it only has one charge. Okay, but if it has more than one charge, make sure to include the Roman numeral. All right, so here's a table that you can see that shows some of the multiple charges that different atoms have. Okay, again, would you be expected to memorize all of these? No, but in a typical year, you would memorize most of these. And this year, you'll be able to look them up, so make sure you find them in your textbook so that you can identify the actual charge that these different elements have. Now, most of the ions that we will be naming are going to be called binary ionic compounds. Binary ionic compounds are going to contain how many elements? 2 elements. Okay, binary ionic compounds have 2 elements. The formula must be neutral when you're done, right? So the positive charges of all of the atoms must add up to the negative charges of all the atoms. So this is going to make sure that you have a balanced charge by making sure you have a balanced number of atoms that are involved there as well. Okay, so how are we going to make sure that we get the right number of atoms? Well, we're just going to adjust our subscripts. When we adjust our subscripts, we're going to see that we can get the right charges for these. So for instance, if we look at magnesium and bromine coming together, you can see that we have an Mg2+ and a Br1-. Well, in order to balance the charges, I would need 2 of my Br-, 2 of my bromine negative ions, in order to balance out with my 1 magnesium 2+. Now, the formula is MgBr2, and that would be the final way to write that ionic compound. Okay, now we use what's called the crisscross method in order to help you figure out what the number of subscripts should be. So if you take the charge that you get from the periodic table and you make that charge move down and come to the lower part below the other atom that it's combined with, then you will basically take that number and it now becomes a subscript. Okay, so you're like, well, Powers, can you tell me what you're talking about there? That seems kind of confusing. Sure. So again, what we have is, let's say I have sodium, and then I have bromine. Okay, you just saw magnesium and bromine. Sodium has a 1+ charge, bromine has a 1- charge. I crisscross these, that's a 1, and that's a 1. Now, when you have your final compound, it's NaBr, you don't need to write Na1Br1. If there's just one of something, you don't have to write that 1 down. Let's try another one. Let's take aluminum. Look on the periodic table and tell me what aluminum's charge is. Aluminum's charge is 3+. And now let's take magnesium, let's take sulfur. We don't want to put 2 metals together, right? Let's take sulfur and look at its charge. Sulfur has a 2- charge, right? Because it wants 2 more electrons. So now let's use this crisscross method, and we say, okay, well, the charge of aluminum comes down and becomes a subscript for sulfur. And the charge of sulfur comes down and becomes a subscript for aluminum. And so now our final ionic compound is going to have that structure, Al2S3. Now we're talking about naming here, and so now we have to say, well, how do we name this? What is the name going to be now that we have figured out how to write it out? Okay, so the naming is really easy. Basically, you name the cation with its regular name, in this case, for instance, aluminum, and then you name the anion, but you put an IDE ending on the name of the anion. So sodium and chlorine become sodium chloride. Titanium and bromine become titanium bromide. Okay. Now, you notice that on titanium bromide, we put a little Roman numeral 2 there. Okay. The reason that we put the Roman numeral 2 there was because it can have more than one charge. Now, how do I know it's supposed to be a 2 and not something else? Well, what I do is I look at the formula. The formula has a bromine with a 2 underneath it. And so that means that I have 2 negative charge total for my bromines, which means in order to balance out, I have to have a 2 positive charge with my 1 titanium. And so that's going to mean that it's titanium 2 bromide. Okay, so we always determine the charge of our anion before we figure out what our charge of our cation is. So let's do one like, let's say we had Fe S. How would I know what this would be? Well, I start with my anion, and I know my anion's charge is 2 negative. It's in that 16th column. And so now what would iron need to be in order to balance out with a 2 negative? This whole thing has to add up to 0, and so it must be a 2 positive. So a 2 positive and a 2 negative balances out to give us a 0. And so in this case, I say, oh, well, this must be iron 2 plus. And so if I were writing the name, I would do iron, and I would put Roman numeral 2, and then I would do sulfide. Okay? Again, the anion is going to have an IDE ending. So you're going to take the sulfur, and you're going to change it and give it an IDE ending. Okay, let's try something that's maybe a little bit different. Let's say I have a nitrogen at the end, and let's say I've got, let's say I have 3 of those, and let's say I have 2, try that again. Let's say I have 3 of these and 2 of these. Can I now determine what my overall charge of iron will be? What's my iron compound going to be? Well, I start with my anion, and nitrogen's charge is a -3. But I have 2 of them. So 2 times a -3 is a -6. I need all of my irons to balance out with a -6 to become a 0. And so I have 3 irons. So how many of my irons at what charge is equal to -6? Well, it must be a +2 charge, because 3 times 2 is 6. And that way my +6 and my -6 are going to be equal to 0. So I now know my charge of iron is iron 2 plus, and so I'd say, oh, well, this is iron 2 nitride. See how that works? Okay, so that's how we go through and we name these compounds. All right, so now let's try it with some other ones. And this is a time for you to do your practice, right? Okay, so what we're going to do is we're going to pause and practice as you do these, and then we'll go through the answers, okay? And we're back. Okay, what we have done, we've got magnesium and iodine, and we have to write the formulas for compounds formed from those, and aluminum and oxygen, and then we have to name the calcium and bromine and copper and chlorine elements. So let's see what we came up with. For magnesium and iodine, the way that those combine, Mg has got a 2 plus, iodine has a 1 minus, and so my 2 crosses over to my iodine, and I should have MgI2. If I were combining aluminum and oxygen, aluminum has a 3 plus charge, oxygen has a 2 minus charge, so if I crisscross the 3 from aluminum there and the 2 from oxygen there, I get Al2O3. Did you get it right? For the next one, calcium and bromine, what are those going to be? Well, calcium only has 1 charge, so it's calcium bromide. And copper can have more than 1 charge, okay? So it would have been calcium bromide. And copper can have more than 1 charge, and now we have to look, what does it combine to? It's CuCl2, so it has chlorine has a -1 charge, which means my total charge of my chlorines is -2, because I have 2 of them. So that means copper has to be something, since there's only 1 of them, to balance out with my -2s of my chlorine to equal 0, which means that this must be a copper with a 2 plus. So we'd say copper, Roman numeral 2, chloride. Now, we have to remember that this Roman numeral is the charge. Over and over and over again, I'll have students confuse themselves, and they will put that 2 thinking it's the number of the coppers. So they would have said on this one, they would have said copper 1 chloride, because they see 1 copper. It's not how many you have, it's the charge of what you have, okay? All right, so let's look at what would happen if we had a polyatomic ion. Okay, so here we've got a polyatomic ion or a ternary compound, ternary just means like 3 or more, I'm still going to name my cation and then I'm going to name my anion. Remember, anions have the IDE ending. Unless it's a polyatomic ion, and then it might just keep its name just like it is. So for instance, there's a list of these elements that you're going to need to look up and memorize. And you would see CO3 2- on that list. And that is carbonate, okay? So carbonate is CO3 2-, and so I would name the anion just like it is. Ka is potassium, and so I'd name its ion just like it is. It's just K2CO3 is potassium carbonate. Now, if I wanted to write the formulas, then I'm going to go through the same process unless I have more than one polyatomic ion that's needed to balance the charge. If so, then I need to put parentheses around that whole polyatomic ion to identify it as a unit, okay? And then I'm going to use that subscript to indicate the number that's needed to go on the outside. Remember, it's very important, do not change the formula of the polyatomic ion. Do not change the formula of the polyatomic ion. So we have an example here of aluminum sulfate, okay? And what we want to do is look at how we came up with this formula. Okay, so let's look at it. We have aluminum and sulfate. Now you're like, how do I know that sulfate has a 2 negative charge? Well, you would have to look that up in your book, and you'd have to access the book for that. So let me show you where that's at in your book. If you go to chapter 7 and you look on page 209, okay, you're going to see that there's a table with a bunch of monatomic and polyatomic ions. Okay, so this is page 209, and you can access that. You're going to need to access that over and over again for the test and for this whole chapter. So make sure that you know where to find those. You can also find some useful information on page 214. Okay, that's where the polyatomic ions are. Sorry, the page 209 is the monatomic ions. Most of those can be determined from the periodic table, okay, because you can identify those pretty easily by looking at which group it's in, unless they're more than one charge. Like this one only has one charge, but if there was something else you might need the book for if it had more than one charge. And then on page 214 is the polyatomic ions. So on page 214, you can identify the polyatomic ions, and again, that's one that you're going to want to be able to access over and over and over again. Okay, so page 209 and 214. All right, so now I have my aluminum and my sulfate, and I've got to crisscross my charges. So my 3 comes down here. Now remember what we said is that if it's a polyatomic ion and you're going to have more than one of them, you've got to put parentheses around it and put that number on the outside. The 2 from sulfate is going to come over here, and so it's going to be Al2SO4 3. And that's how you do polyatomic ions when you have something like this. And again, how do I know the name? I name the cation and I name the anion. Sulfate's name is something you would have to memorize and or access by looking it up. Okay. All right, so let's look at some examples and see if we can do some of these. What's the formula and name for the compound formed by Na plus and SO4 2 minus? Okay, so these are good pause and practice ones. So let's pause and practice. And you'd get sodium sulfate as the name and Na2SO4 as the formula. Well, I guess you don't really need to pause and practice. You get to see the answer right there, don't you? Okay. What is the name of copper CuNO32? Okay, that would be copper 2 nitrate, because there's a 2 on the nitrate, and that's the stock system that we're using, right? It has a 2+ charge for copper. And then What is the formula for the compound form for magnesium and carbonate? Well, then you just put down the Mg, and then you do the CO3. Now, let me show you something real quick on that one, because that one has something a little bit unnecessary that you don't have to put on there. Well, at least some people put something on there they shouldn't necessarily. This is a 2 plus, that's a 2 minus charge when you look them up. I don't need to, when I crisscross, I don't need to do this, because if they're the same, because it's a polyatomic ion, and I'm sorry, because it's an ionic compound, I just need the lowest whole number ratio of my elements, okay? This is only for ionic compounds. This is not true for covalent compounds. But for ionic compounds, I just need my lowest whole number ratio, so I don't have to have the 2's after them. I can just leave it as MgCO3, okay? All right, so now let's look at some others that we can practice. I keep giving you all the names. This new format has all the names that come up on it. So, all right, so you can look at those and see if you can figure those out. Cover up the right side and try and figure them out on your own, and then see if you got them right. All right, so your sodium chloride is NaCl, iron 3 acetate is an Fe with the parentheses, C2H3O2 and a 3 outside the parentheses. Aluminum bromide, AlBr3. Lead 4 oxide. That's a kind of a tricky one. Let me go back and let's do lead 4 oxide real quick. Because again, with the with the ionic compounds, it's the lowest whole number ratio, right? And so if I've been given lead 4 oxide, I would write lead, and it's a 4 plus charge because the 4 indicates the charge. And then the oxide, that's oxygen, and I know from the periodic table it has a 2 negative charge. I crisscross them, that has a 2, that has a 4. But again, lowest whole number ratio for ionic compounds, I can reduce that to a 1 and that to a 2. And that's why when I write my final answer, it's PbO2 instead of Pb2O4, okay? It would be incorrect to leave it as Pb2O4, all right? Pb2O4 would be wrong. You'll get that wrong, so make sure you reduce ionic compounds to the lowest whole number ratio, not covalent compounds, though, okay? Then if we write our names of the other ones, lithium sulfate, and then cobalt can have more than one charge, so cobalt-2 nitride, okay? Binary compounds have the IDE endings on them. The polyatomic ions don't have the IDE ending on them. They just are named according to what you see in the book on page 214. Although cyanide has an IDE ending and it's a polyatomic ion. And then zinc carbonate. Zinc only has one charge, so you don't need to put zinc 2. You just put zinc carbonate. Okay, so let's continue on to the next one. And, oh, we already did that one. Let's go to this next one. So, let's see if you can figure out the name. So you actually get to practice this one without having the answers given to you. You actually can figure out the name of MgF2, the chemical formula for sodium oxide, the name of FeF3, and the chemical formula of lead 2 oxide. So maybe go ahead and pause and practice that, and I'll go through the answers now for those. Okay, so MgF2, we've got magnesium, that's Mg, right? Just name it just like it is. Magnesium, and then fluoride. Now, fluoride and fluorine have a very interesting spelling. Make sure you pay attention to this because this is the most commonly misspelled word in chemistry, and that's fluorine, and it's FLU, like you have a flu, fluorine, okay? Magnesium fluoride. Chemical formula for sodium oxide. Here's sodium and oxygen. Oxygen has a 2 minus charge, and so it transfers down, and so it's Na2O. Name of FeF3. Well, fluorine has a negative 1 charge, and so iron, since there's 3 fluorines, it needs to have a 3 charge to counteract those 3 fluorines' negative 1 charges. So this is iron 3 fluoride, IDE endings for binary compounds and for ionic compounds, or for binary ionic compounds and for the molecular compounds, which we haven't talked about yet. Chemical formula for lead-2 oxide. We'd have lead. We know that it has a 2 on it, and oxygen also has a 2. So if you crisscross and reduce, it's Pb2O2, reduce it down, and it's PbO. So there's lead-2 oxide. Did you get them right? Hope so. They're fun to do. I hope you like doing them. They're a lot of fun to do. At least they are for me. All right, so now you've practiced some of those. Now let's go on and let's see. I'm going to leave that for later. You're welcome to practice some of those later. But I'm going to go ahead and skip on to skipping that one too. And skipping that one. You guys can practice those on your own or practice them in class when we have a chance. Well, I'm skipping all this. They're not grading our homework right now. I got to get to the molecular compounds or the binary ionic compounds. Oh, there we go. Are we there yet? I'm so not there yet. Okay, wait. That might have been it. It's a new system for me. All right, there's our objectives. Write formulas and names for binary covalent compounds by using prefixes, roots, and suffixes. So notice that the big difference here is that we are now dealing with covalent compounds. Okay, so this is covalent compounds instead of ionic compounds. But it's actually even easier than ionic compounds in a lot of ways. So given a covalent compound, you'll write its name, if you have the formula, and given its name, you're going to be able to write its formula, right? Now, why is this important? Well, this is kind of a fun one. You guys have probably heard or seen something like this at some point. There's some articles that we sometimes show to you guys in class that are called ban dihydrogen monoxide. We have you read this whole thing, and we have students ask, okay, would you ban this as well? And most students are like, yeah, I'd totally ban this. This is dangerous, because we talk about all the stats of how many people it kills and how dangerous it is and how it destroys all sorts of property. And so people are like, yeah, ban DHMO, dihydrogen monoxide. Well, it's actually just a name, okay, for water. And so it's just kind of fun to, kind of play with this concept because when you understand how to name things, it's kind of humorous to play with somebody and mess with them on DHMO. All right, so what do we do to name these things? Well, like I said, it's pretty easy. We're just taking a numerical prefix to tell us how many atoms there are. Now, we do that for every single atom that's in that molecular compound, unless it's the first atom in that element series and there's only one. Okay, so in other words, if I have just one of my first atom in my little compound structure, I don't have to say the prefix on that one, but I'm going to say the prefix for every other atom that I have in that molecular compound. Remember that we typically are going to put the least electronegative element first in the naming, and the more electronegative element is going to come second. Okay, just pretty much like what we had for ionic compounds. The ionic compound cations went to the left and then anions went to the right. It's kind of the same thing here. The more electronegative go to the right on this one. Okay. All right. So remember that second element always gets the prefix IDE. I think you guys are going to enjoy a little chemistry humor here. Would you like to hear a joke about nitrogen monoxide? Oh, no? Oh, okay. Well, fine. Rude. All right, so can we name SO3 and can we write a formula for carbon tetraiodide? Well, in order to do this, we're going to need to know what those prefixes are, right? We've got to be able to use prefixes. Now, the prefixes are found on page 216. Okay, so let's look at how we would name these. You're going to have to look on page 216 of your text, and you're going to see the Greek prefixes. Now, don't get confused. Sometimes Latin prefixes are used in math, and we're using Greek prefixes here. And so there's a couple that you might get a little mixed up on, but things like tetra is Greek, but quad is going to be Latin. So if we do SO3, I just have to name my first one. There's only one of them, so I just get to name it. And then I name my second one, right? My least electronegative atom went first, and my most electronegative atom goes second. And so I have to say trioxide. I drop off the ending of the oxygen, and I just say sulfur trioxide. Pretty easy, right? If I do carbon tetraiodide, I have a C for carbon. Again, there's just one of them, so I don't have to have a mono in front of that. And tetraiodide, tetra, if I look on page 14 and memorize those, I get that is the number 4. Okay, so that's pretty easy, right? Makes sense? Not too hard. Now, I do have a another video that I have for you that is a walkthrough, and it's just kind of like got a logic chart, kind of like a logic tree, where you can follow the path of how do I name a compound. And I find it very helpful to go through and say, okay, is it this or this? And then I go this way. And is it this or this? And then I go this way. And so you will be able to watch that and use that as a video to help you kind of understand how to take any compound and then go through that little logic path and figure out the name. Okay, so here we have a catalyst that is kind of a fun one to do. Chemistry students were asked to name the compound NO3. Student A says the name is nitrogen trioxide. Student B says the name is nitrate. Who is correct? And explain. All right, if you think about that, give you a second to pause and answer it and then come back. The student A is the one that's correct because the nitrate is the name of the ion. And in order for it to be nitrate, it would actually have to have a NO3 negative charge on it. So it would be NO3 with a negative sign up there. That's nitrate. But if it's NO3 all by itself, it's not an ion, then you would say nitrogen trioxide. Okay. Now the next one, chemistry students were asked to name the compound Ca3P2. Student A says the name is calcium phosphide. Student B says the name is tricalcium diphosphide. Student C says the name is calcium phosphate. Who is correct? And explain. All right, so think about that for a second and pause and then come back. All right, and so our answer in this case is calcium phosphide. Student A is the one that's correct. Why? Well, because calcium is a metal and phosphorus is a nonmetal. And so this is a metal-nonmetal combination. It's an ionic compound. And so the first question, remember, you have to ask about naming a new compound is it ionic or is it covalent? Because those two ways of naming things are different from each other. Okay? And so that would be the name of that one. Okay? All right. So, have we now met our criteria of success? Yeah, I think we have. We now are able to take covalent compounds, ionic compounds, polyatomic ions. We can take any of these formulas, put a name to them, and then we can take the name and put formulas to them as well. Okay, so excellent job today. I hope you guys had fun. I don't know if you'll like this new format of doing the slides. It's a little bit different for me, for sure. I'm trying to figure out what's on what slide, and the answers are all there, and that's my bad. I didn't realize that as I tried it this first time. But hopefully you guys had a good time today learning about naming compounds. And if you guys have any questions, please make sure to talk to me. We usually practice this a lot in class, and we're not going to have a lot of in-class practice. So you guys have got to master this stuff on your own. So make sure you go through and identify and understand how to do this stuff. Okay, so that's all I got for you today. I hope you have an awesome day. I hope you are practicing kindness with one another, because that makes all the difference in the world. And yeah, I guess that's it. Chill, we're out. God bless. Bye.